The two states that have regulations that are passed in the U.S. are Maine and Minnesota, and both those states are looking at essential use exemptions. I'd like to see an increase in women decision makers.
Welcome to Polycast by UT, the podcast from Urethanes Technology International, where we talk markets, business, and big trends across the polyurethane industry. I'm delighted to be joined today by Mary Bogdan. Mary is a research fellow and recognised expert in foam blowing agent technology with more than 30 US patents under her belt, which is a Six Sigma black belt, by the way. Mary has played a pivotal role in the global introduction and support of HCFC, HFC and HFO technologies and continues to drive the development of next-generation foam blowing agent solutions. Since joining Honeywell in 1989, Mary has held numerous leadership roles in R&D and currently leads the foam blowing agent team of spin-off Solstice Advanced Materials. As Solstice begins life as a standalone company, we're going to talk to Mary today about what changes, what stays the same, where blowing agents go next, the future of low GWP technology, and how the industry can bring through more visible female leaders. Welcome to the podcast, Mary.
Thank you for having me, Stephen. Excited to be here.
I've had the pleasure of meeting you, Mary, several times over the last year and seeing at first hand the huge levels of respect that follow you in the industry. Now, if I could start with Solstice, obviously Honeywell completed the spin-off of its advanced materials business in October last year. Solstice Advanced Materials trading now as an independent company. So for polyurethane customers, what's changed and what stays the same?
Okay, what has not changed, and this is really critical, part of our future is we've not changed the people, we've not changed the facilities, and the products sold. So we are selling the same items, made in the same places, and supported by the same people. The mission of Solstice, however, is slightly different than what Honeywell had. Our mission is to advance innovation to improve what matters. Customers are a key part of this mission, and it allows us to be more independent and flexible. We can move much quicker, and this allows us to focus on, benchmarks our current products, make them better, as well as exciting points in the future. We have a lot of ability to become innovative and creative, and we've invested immensely in our R&D facilities and in our manufacturing facilities. The change is very visible.
That's great. And one of the things I wanted to say to you, actually, we covered your latest financial results last week. One of the things that was an interesting clip from those results was the upping of R&D spend. So how much, if any, of that is on molecules destined for use as blowing agents?
So I've been with this firm, for 37 years. We are always looking at the next greatest and best material. There's always a challenge in the environment, and there's always a way to make something better. In the site I'm at in Buffalo, we have increased our headcount from about 100 people to almost 200 in the last year. We have put sizable investments to our R&D facility, and we are looking at having whatever we need to move forward. In our foam lab alone, we've put substantial improvements in equipment, as well as getting new equipment, which allows us to do so much more than we have previously. It's an exciting time.
And the name Solstice itself, that was a blowing agent brand name, wasn't it, beforehand? So does that create nice synergy for foam producers? So there's a continuity there?
It is a synergy, but quite frankly, it's Solstice Advanced Materials, not just Solstice, but Solstice is a new beginning, right? It's a rising. When you think of what the word means, it means that we're looking for the future. We're looking to make, light, find light and make life better.
For customers who have sort of come over with you, of course, companies who might hear about a spin-off happening, their first concerns might be, is there going to be an issue with supply continuation, with service, with technical support? What were they most concerned about? And have there been any teething problems that you've had to get over?
Well, I think since we've all survived COVID, the first thing that anybody is concerned about is supply, right? Is this going to impact my supply? And how is it going to impact your supply? And quite frankly, Solstice Advanced Materials looked at this. We actually started with a soft spin in August of our company so that we could get everything lined out so there wouldn't be a problem at the transitions. We looked
Right.
for no disruption, in the supply chain and what we were
Hmm.
providing to our customers. And, we believe we've accomplished it. But in anything, there's always a chance for something you hadn't count on. And we have weekly meetings on a corporate level to bring up anything that might not be working, and it can be immediately resolved. There's a team looking at that from every possible angle.
So, what are your market priorities right now?
Well, I think, it's looking to innovation as well as supporting the bench. I mean, we have core competencies and long-term commitments in blowing agents. Okay. Blowing agents
Mm,
is a key component of this. When we look at the global market, there's a lot of things going on in the global market. Obviously, there's regulations going on. We're looking to meet those drivers, but we're also looking for areas that maybe polyurethane foam and, basically insulation has not looked at. So we are looking at everything.
mm.
That's the advantage of what's going on here. Looking at where the possible next gen might be coming from, or what you might be looking for. What are architects looking for? What are our
Mm.
customers looking for? Not our immediate customers, but our long-term customers. What are we seeing as megatrends, and how do we meet those?
Is Solstice working on another generation of blowing agents that is even greener?
My common answer to this is after doing all these transitions is I'm an R&D. It's what R&D does, right? We are always looking for something better, something different, and to meet the regulatory requirements of the world.
Yeah.
So, yes, we are. Can I get into details? No, but there's always, I mean, that's what I'm paid to do, right?
And obviously blowing agents is going to be a big part of our conversation. Um, you've personally seen the industry move from CFCs to HCFCs to HFCs, now HFOs, and other low GWP systems. Which of those transitions was technically the hardest? What did the industry struggle with?
I think the toughest transition was the one that went from HCFCs to HFCs because you went from a material that boiled substantially higher. You went from material that boiled, say, at 25, and now you replaced a material that boiled at 10. See, that's a big difference.
Mm,
So what happens? We had a material that we shipped in drums. Customers were used to pumping it, leaving it outside, not really thinking about it, into a material that now is shipped in cylinders. So it changed how
right.
they did everything. And when they
Yeah.
did that, quite frankly, when you look at the original CFC and HCFC technologies, they weren't as efficient. When I first started looking at them, you could see that maybe we used blowing agent as a diluent instead of a blowing agent. We had the ability to do that. We weren't as didn't have the
Mm,
environmental considerations or the limitations. Now we are very focused on what can we do and how little can we use to get to what we need. How do
yeah.
we meet those insulation requirements so that we're not emitting materials we don't have
Mm,
to. So those changes in each transition, you've seen substantial changes in the formulations, but the formulations have produced better lambda materials, lower lambdas,
yeah.
or higher R values, and they're doing it with less material. So the transition's been exciting, but the toughest one
Mm.
was the first one when you went from a high boiler to a lower boiler material, at least in my mind.
It's interesting, and I've been in this industry for just over a year, and there was almost an assumption that refrigeration, cooling was a big part of blowing agents, but really transitions for blowing agents, you're kind of subject to the whims of construction market. I would say maybe predominantly here. Um, is it fair to say that pace of transition is dependent on things like building codes? You mentioned system reformulation, commercial roofing changes, though, what main factors are at play within the construction sector that are impacting these transitions?
You're absolutely right. Regulations drive these transitions. There's no question about it. They're looking at building codes. Those are getting tighter. They're
Mm,
looking at, for instance, embodied carbon. That's something that some municipalities are now focusing on. They're looking at emissions. What are the emissions from materials? What is the life cycle of those building materials? But mainly, they're looking at efficiency and effectiveness. When we think about it, when you spray a foam on a roof, you want to get the biggest yield, right? everybody is very cost considered
Mm,
today. You've looked at beyond operational energy to embodied carbon because that drives pricing, right? If it,
yeah,
for instance,
yeah.
with a spray foam contractor, if his gasoline or petroleum price has gone up by 40%, then it's going to cost him more money to get to the job site. So you have to
Yeah,
have efficient
yeah.
material and it has to rise and you need to make more with less.
We talked about the construction sector being a softer market at the moment. Has that slowed the uptake of low GWP blowing agents, or does that transition progress regardless of all of that?
It actually transitioned and a lot of so there's two reasons for a transition. One is regulatory.
Mm,
For instance, in North America, the US, the HFCs have to be less than 150, which means that blowing agents transitioned even before the snapping of those materials or the regulation phase out of those materials. Some states did it even sooner than that. But the other thing is, what are you getting for it? People who are insulating a building are buying for their lambda per
mm,
dollar or their R per dollar, right? I want the
yeah,
biggest amount for my money. And, if you have a product that's more efficient and more effective, then they're going to pay the money for that because at the end of the day, the energy savings is very critical. In some instances, you're looking at commercial dwellings, multifamily dwellings. They're taking a big space in a lot of geographic regions now. They're becoming more critical. And those require significant insulation.
if we had a low GWB blowing agent in a spray foam, um, do application procedures then change? Do we need different temperature control, pressure settings? Do we need more blowing agent for the same result?
No, no, actually, what the market as a whole is looking at is less blowing agent. This is what the
Mhm.
formulators want. They want less blowing agent with a high R
Yeah.
value. If you or low lambda, if you look at the numbers that you're seeing in spray foam, and most recently there was a polyiso board stock introduced in North America, that the trend is a lot higher R value. That one came
Mm,
in, I believe, at an R value of 8, which lambda is that's a pretty significant increase from where they were. And,
yeah.
people are looking, so then I'm transporting less insulation, so that saves it. It's less job time.
Mm.
The efficiency is far greater. So you're looking at a cost effectiveness across the whole building assembly then.
When we look at blowing agents today, then HFO blowing agents, where are they particularly performing in the polyurethane sector today? Where do other technologies perhaps retain a legitimate place?
So HFO technologies, when you look at the long position of them in the market, or just any fluorocarbon-based insulation, it's
Mm,
designed for low temperature, ideally low temperature applications. That's where the energy savings is there. That's why they've been used from day one, and that's what you see here. They're closed cell, which means that they bring, air barrier components to it. And they're rigid.
yeah,
All those applications bring a lot more to the building assembly. And that's in essence, you get that there's a match between the technology and the application. But for
understand.
instance, if you look at spray foam, the wind uplift is substantially better in a closed cell spray foam. In essence, you've kind of glued your roof to your structure. Severe
Mm.
weathers. If you're looking for subsurface applications, those are closed cell foams, and they can take load on them.
What are companies most concerned about in blowing agent conversations? Are they looking at low GWP energy? Are they looking at embodied carbon, supply security? What are the main concerns for companies?
Well, I think a key driver, okay, in any area is regulation, right?
Okay.
It drives how much you can sell and where you can sell it. I think that you've seen in regulatory markets, you've seen a transition from not only the federal or the high level regulations to now things coming
Mm,
into, regional or state regulations. So I think that it's always a concern for a company. How is that going to impact it? Because folks are looking for global supply opportunities. They
yeah.
want to make one product and sell it across the globe. And looking at that is always a key consideration. But I think when you think about embodied carbon, that particular aspect is looking at not only the energy savings in the building, but the energy it costs to make the material. And it's looking for a balance there. It's looking for getting the most energy
Mm,
savings with the least cost of raw materials. And that's becoming a driver. And for instance, Canada has some proposed legislation around embodied carbon. You're seeing some states in the US that are looking at that. So again, it's a regulatory
Mm,
focus, but it's a focus on reducing energy in both making the material and saving the energy in the
yeah.
building, which is a good marriage.
So obviously, you're based in the US. So I've got a fly in the studio today. I think he wants to
He wants to
take
join
on,
us.
yeah, ask you some questions. Um, the the transition to HFC in the States in polyurethane foams is essentially complete.
It is well
Um,
completed, yes.
so is it a challenge keeping low GW replacements available because of broad PFAS definitions that we face across different states? Because as you mentioned there are different things in different states, different concerns, different regulations, different legislations. So how does PFAS affect that?
I think you need to kind of consider PFAS as what the definition is, and that's really a thing that we're looking or a focus that everybody is. At the federal level in the U.S., PFAS is the legacy materials. Okay, they're long-lived, they're bioaccumulative, they don't decompose in the environment, so they bring to the issues, the health concerns that we've all looked at since I'm from the time where you did have Scotch Guard and everything on kids' clothes and that, so you bring that to the form, and I don't
Mm,
think anybody debates that those chemicals are legacy and they were phased out for a reason.
yeah.
I think the challenge becomes when you go with a definition that is too broad. You classify it by a
Mhm.
chemical definition, and I think in some instances those decisions are made by people that aren't chemists. I think that they don't necessarily understand everything that's being implicated.
Yeah.
And when they step and realize that, then there's pause and people are considering it. For instance, the two states that have regulations that are passed in the US are Maine and Minnesota, and both those states are looking at essential use exemptions. Okay,
Okay.
it's like, so okay, we're trying to step back and
Mm,
understand where we need these materials. So they're kind of doing the responsible care component of it. It's okay, we think that there's materials that could be used in some places, but is it essential? And that's quite frankly when you put a fluorocarbon into the market, you submit it, at least in US, you submit
mm,
it to the EPA and it undergoes a SNAP evaluation. And let me tell you, that's a very significant evaluation. It's not only how we make it, it's what's the impact in the environment we're making in it,
yeah.
what's the exposure to people. There's significant work done in that. So it's already cleared those hurdles. So it's just a lot of it is education and understanding where it's used and why it's used.
Kigali Amendment to the Montreal Protocol, that states phase down of HFC production by 80 to 85% by over the coming decades. Now, of course, we see different results in different locations. So, developed countries, you've mentioned a few already: Canada, the US, target, I think, was 40% by 2024, 70% by 2029. Um, do these targets, considering everything that's going on at the moment, do they remain realistic in your opinion, Mary?
Um, so the targets often don't only consider blowing agents. Okay, so I can speak on blowing agents.
Okay.
It's very realistic. In those countries, in the developed countries, we've already phased out of these.
Yeah.
There really is not a concern here. We've transitioned to those technologies already.
In hot climates, for example, is it more a challenge? We see the Middle East, we've got some maybe some extended deadlines. I don't know whether that's because of the hotter climate. Some Asian countries maybe have targets long term into the distance. What affects those targets that they're working to?
Not country specific, but if you take
Mm,
a big, approach on this, the 50,000-foot level, your transitions are based on technology capabilities. Do you have the ability to do this? Do you have the pots and pans and kettles to do this? How advanced is your manufacturing or your transportation or use structure to support this transition? Why they're not considered equivalent next necessarily because the developing components are different in each part of the world.
If you have a freeze, we hear about the freeze year. What's supposed to happen, of course, is that sectors then convert when the legal freeze begins. In your experience, how quickly do sectors convert from that freeze stage when maybe the first mandatory reduction step might be several years away?
I think you need to consider that whenever you bring a new technology to market, particularly in a building component or
Mm,
even a refrigerator, you have to go through testing, right? I mean, it can take multiple years to get the flammability testing and everything done to bring a new building material to be building code.
Yeah.
So that's not something that you're going to do at the drop of a hat. That's something that you're planning well in advance for. Whether they launched a product prior to that date or that, but if you're going to be commercial on that date,
Mm.
you've had to do research long before that.
Do certain geographies on later Kigali schedules have an opportunity to leapfrog technologies?
They do. And I think that the advantage that they have, for instance, when we were speaking in Dubai, you asked whether I thought that they should go to HFC or HFO technology. And I said, quite frankly, the HFC has a lower boiling point. So I think that it would be far easier, based on what we've seen on transitions, to them
Yeah.
to transition to the HFO technology because it would be easier. The other advantages that these countries have is some of this has already been looked at and researched, right? You have the catalysts, you have the raw materials. All this is ready now. You're not
Yeah.
waiting for another supplier other than us to get something. The point is,
Mm.
and there's been papers published by CPI that talk about what catalysts work well, what you see for energy efficiency. You yourself publish a lot of information, what the trends are, what people are seeing, what bio-based materials. I think that the transition for those countries is actually a little more efficient. Wouldn't say easier because being a
Yeah.
person in the lab, nothing's ever easy, but it is more efficient because you've got a bigger database of materials and things to call on.
Would the US have done anything differently in hindsight? What that experience of transition, what has it learned, do you think, as a sector? Would it have done anything differently?
No, I think that when you look at, and this is true for every economy that I know of, those COVID years,
Right.
had a
Yeah.
big impact on transitions and
Yeah.
technology. I
Yeah.
think that the marketplace would have looked different if we didn't have a 2-year gap there on a lot of
Yeah.
things and the ability to do a lot of things. Basically, could you get into a lab? Could you do what you needed to do? Were test labs open?
Yeah.
That had a substantial impact. So I think
Mm.
that was the greatest challenge. Is everybody always trying to make things better? I mean, as anything, you put out your first version, and then there's always version 2 and version 4, and you're getting better with everything that's
Mm.
coming out.
Do you think industry is too fixated on GWP, and maybe insulation efficiency or embodied carbon is more important?
So I think that all those are components of a regulatory environment and also a consumer environment.
Mm.
So what is the consumer driving? And a lot of our areas, people buy more energy efficient cars
Mm.
when when the petroleum price goes up, right? you know, and you're seeing the advent of hybrids and other things because in essence, energy costs, once they become difficult and hard and expensive, then people think about insulation. It
Yeah.
becomes critical because dollars and cents make the difference. Embodied carbon, how much that's driving what it's going to cost to make
Mm.
that insulation, as well as how many parts are in that wall assembly.
Yeah.
That's something that I learned by investigating embodied carbon more closely with some folks from Elastichem
Mm.
because it pointed out when we actually had assembly diagrams made for architects, so it was easier for them to reference them to see how many different components there were and what each one of them drove. So if you could
Yeah.
take 3 parts out, made a big difference in the energy required to build that assembly.
Well, you've brought us nicely onto that presentation that you presented with Elastichem. What did you want the industry to take away from that paper?
What we need to take away from that paper is that the fact that as an industry, one, it's important. I have children, you have children. The resources on this globe are limited. And so I think that we need to think about not just the energy efficiency, which we've all been very driven about and improved substantially, but also the costs of manufacturing from an energy perspective. Are you using coal fuel? Are you using nuclear fuel? Where's your energy
Mm.
source? How long are you transporting things? Where are those sources coming from? We do a lot about foodstuffs, but I don't know that we've thought as significantly about manufacturing realms here. And this kind of, in essence, points out how do we make this more
Yeah.
effective?
Architects are obviously very influential when it comes to material decisions. So What do you think they understand well about polyurethane? What do they still need from the industry? What do they need to understand better?
They do an excellent job. I could not be an architect. I don't have that vision or what they do. I'm the nuts and bolts person in the lab. I'm the lab geek, but they rely on the data we give them.
Yeah.
Okay. And I don't know that they use a uniform testing program or uniform things representative of the values. I don't know that in their educational component that they actually think about what that number means. Maybe there's an R value presented in India, and that's measured initially, where the lambda measured in the U.S. is 6 months, or maybe it's thin sliced. They're looking at a number. They
Yeah.
just look at that number and then design around that number. In some instances, for instance, there's a big component going on with the SPFA around A value, which basically says you're combining both the insulation component and the air infiltration component. Because sometimes to get to an R60, you're putting a crazy amount of insulation in when you're not taking
Yeah.
air
Yeah.
infiltration. So in essence, you're using too many resources in that structure, and that's not helping you. The
Yeah.
effectiveness of that insulation goes down the thicker it gets.
Before I move on to women in polyurethane, which is an important part of our conversation as well, um, I wanted to ask you how you explain your own company's products. So the difference between, I know you have Solstice LBA, you have Solstice GBA. So in terms of applications, where do those products sit?
So one is a liquid and the other's a gas, which is
Okay.
where the LBA and the GBA came from. Okay, one
Right.
has a boiling point around 19, the other one has a boiling point of minus 19. So it's pretty straightforward from that component of it. Now, where they used is interesting. The gaseous materials serve two purposes. One is the purpose of a propellant. For instance, foam in a can. It also
Okay.
drives the propellant out. Okay. It's used in meter dose hailers. It's that gas that comes out. Different purity profiles, but the same basic material. So it's used in areas where a gas is needed. It's used in extruded polystyrene. It works very well in those applications. After you melt it, it comes out of the extruder and goes puff. Now, the advantage of a gas is that when you get to extremely cold temperatures, it's not going to condense. Okay, it's going to stay
Mm,
gaseous. So the impact of the low temperature thermal performance is improved. The
yeah.
liquids are used in areas, particularly where you're looking for low R values. Think if you put a polyurethane system in a refrigerator and you want it to flow, you put
Yeah.
spray foam on, you need it to transition. When you do the gas, it's like shaving cream. It comes up very quickly. An interesting application is in Japan. Japan uses both a gas and a liquid blowing agent up in Hokkaido. They'll add a couple percent of the gas and they'll go poof. The insulation comes off the wall and it's not as big of a heat sink. And they get substantially more yields where normally in a cold temperature application, you would get some pullback because remember it's
Mm,
a physical blowing agent. So if the temperature's too cold, it's not going to be able to rise. It'll rise and then it'll kind of sink back. That doesn't
right.
happen in Japan because of the way they approach it. So we sell both of them. They have very different markets, but they're both insulating
Mm.
gases.
Final question before on blowing agents. When will the world be done with high GWP blowing agents, do you think? Will it be before 2047?
So that's a good question. I think as we look at the world, we are selling products to each other. Products are transporting the globe constantly. If I had a money to wager on it, I would say you probably are going to see a transition quicker than that
Mm,
because there won't be a supply for it other than in that immediate country.
yeah.
Countries are becoming very focused on energy efficiency and they're also becoming very focused on their climate.
The topic of women in the polyurethane sector is an important one. We've had several conversations about it over the last year. You've been in the industry for more than 3 decades. We're obviously very passionate about polyurethane. We had Audrey from Purecom the other week, and she was great, and she does a great job as well in promoting women in industry. What's your view on where we are right now? What has genuinely improved on this front during your career in the industry, Mary?
Well, so I want to say thank you. Probably the first women in technology panel I was on was one that you sponsored in Dubai. And it really made me realize how much women had gained
Mm,
in traction and position and and influence when you're busy in a job day to day, you don't necessarily see outside of your own sphere. And it was so exciting. I walked away so, enthused about what we'd done. That was a remarkable panel of women, three women that were all different spots, different
Mm,
points. And, it was good to see what we'd done. When I started, maybe I was the only one sitting in a room. I can remember some people saying, "Are you really going up on that roof?" It's like, well, yeah, or when I walked on when I started here and I walked on a fluorospar ship and, I walked this rope ladder to get on it. And then the gentlemen on the ship were not very happy with me. I guess I was bad luck. It's like, we want to blow, but it's bad luck. It's going to shake the ship. It's like, I just was looking at the fluorospar, folks. Really, it really had nothing to do with anything else. So it has changed so
mm,
dramatically, and I'm so excited about it. And momentum is building. You can see it. People like you started this from a visibility, and thank you. And it's grown. You in
mm,
essence made me feel more responsible. So we did the CPI women's panel. And I recently did one at the
absolutely.
spray foam convention. At the CPI panel, you had Allison Keene and Dr. Jean Vincent and Lisa Massaro Kutchers. At SPFA, I had 5 women, 4 of who are actually spray foam contractors. They own their own spray foam industry. Candace Lord, Edith, Karen, Carla, Courtney, they were all from all parts of the US. Some in the deep south that still
Yeah,
see some challenges
yeah,
in their jobs and what they do. But the point is that the realization that there's other women and there's someone you can phone. Over my 37 years, I had a friend that was a phone a friend. You could call them and say, okay, is it me? Is it the world? I just don't look at life this way. And they'd say, oh no, it's you. Or like, no, that's not really
yeah.
good.
We hear a lot about mentorship. We hear about sponsorship. Um, which matters do you think more for women trying to build in a technical career?
So you need both. Mentorship is that phone a friend. Someone that tells you the skills you need, what you need to do. It
Mm,
helps you drive your career and your education and your skills to where they need to be. Mentorship is critical if you're going to move up in the organization.
yeah,
That's the individual that gives you the hard job. The one that says, well, I don't know if you'd actually make it, but you can do it. But someone's already ensured that you have those skills to
yeah,
to to actually approach it and succeed at it. So they're both really, important to anyone, not only a
mm,
woman, it's to anyone. We need to realize that we all are representing minute we say anything or go anyplace, we're representing the people that work
mm,
with us that may not be sitting there. So that just comes with the territory. But
yeah,
women need to encourage women. You need to step up. You need to
yes,
sit at the table, not behind. You need to volunteer. If you don't have leadership opportunities in your company, then do leadership in your community. Do the outreach for your company because
mm,
leadership is seen no matter where you come from. And if you can organize things and people think, oh, that person can do that as well. Dr. Jean Vincent said she took the initiative. She asked for those roles. If they weren't
yes.
given to her, she said, all I could have gotten was a no. And by asking and bringing my resume and telling them exactly why I should have that role, I got it. It might not have been their first choice because I wasn't even part of
Mm.
the choice.
That was a great conversation. Jean made some really good points, and it was really inspiring and to be in that environment with all those powerful women, all those women that were coming, just entering the industry, some that had been in the industry for many years. And I think learning from figureheads like that that have been there and done it, I think was such a valuable thing for them to be part of. In terms of women entering the polyurethane industry, what are they still up against, do you think, that the industry is maybe not talking about enough?
Well, I don't think it's only women. I think the more diverse our workforce becomes, there's a
Mm,
lot of unconscious bias. It's just things you don't even think about. Did I invite them to sit at the table? We need to talk more openly and
yeah.
express what we want to do and how to do it. And also, if there's something that doesn't seem right, to, to, to confront it.
Mm,
Everybody's entitled to a safe, secure workforce and to have the abilities and to do things and,
yeah.
the challenges and that meet their expectations.
If we looked 5 years down the line, for example, what would success look like for women in polyurethane? And is there anything we need to do differently as an industry to get there, do you think?
So in 5 years, I'd like to see a increase in women decision makers. I think we're rising up in the ranks, but I don't know that we're at the CEO levels. I don't know that we're high enough for visibility. Not only a seat at the table, but leading the meetings.
Yes.
Leading the
Yes.
discussions. And thank you. You are a great proponent of women. The fact that you've had multiple women on your podcast, you are making a huge difference by doing this, because then they'll be sought out for their contributions and knowledge because they see them, they're
Mm.
visible. I think more networks need to be established in the industry, and this is happening. More collaboration and celebration of women's successes in
Yeah.
fields need to be happen. I think that as someone once said, I was just doing my job and I didn't realize nobody saw me doing it. You've hid
Yes.
that light underneath a basket for too long.
Yeah.
There's no problem in letting it shine, letting people know what you're doing. We need to kind of celebrate what everybody's wins.
Absolutely, yeah. And if you had a young female chemist, for example, and or an engineer or technical service specialist coming into the industry, just about to go on her first industry conference, what would you like them to know before they do that, before they embark on that journey?
Maybe what I've realized in life here, and because of where I sit in my life, is time is something you don't get back. You have a
Mm,
limited amount of
mm,
that. We never know how much that is. So if you are going to spend time at someplace like a conference, plan for it. Make sure you know who's speaking. Make sure you know what's going on. Get a list of people. If there's someone there at a company or someone that's a presenter, arrange to see them at a cocktail hour. Have this
mm,
planned, because
mm.
without a plan, you're going to lose your opportunity and you'll come back and you won't have gotten everything you could out of that opportunity. But it takes a lot of time and planning to do this. It's not just I walked up and it happened. You really have to make the most of it. Come
Absolutely.
back and share it. Because now when you come back and you share it, you're not only have you gained knowledge, you're showing people that you have this knowledge.
Mm,
You're reinforcing what you learned and you're sharing it. So now you become an expert in this area and what you just saw and talked about, and be prepared to do that. I think in anything, the preparation up front is critical.
yes, it's fantastic to see the progress that's being made, and long may that continue. I would like to finish, if I may, with just a couple of quick fire questions, just for a bit of fun. Um, and I wanted to ask you, because at the intro, when I introduced you as having more than 30 patents to your name. Do you have a favorite, or is that like choosing between children?
Well, I think my first one was my favorite, because quite frankly, when you think about it, it was like I never considered myself to be an inventor. This was one
Yes.
of these things that you never realize what it takes to do it. And as someone once said, well, it's the aha moment. And that was one that talked about 245. And when you used it, it wasn't a little year.
And now you have more than 30.
I have. So yes, yes. And it's a big part of Solstice.
Yeah,
We spend a lot of R&D, and it's an part of your expectation of your R&D program to make sure that you can find these aha moments, as we like to call them.
definitely. And final question for you. If the transition for blowing agents was a movie genre, what would it be? Would it be a horror, a drama, a slow burn documentary? What would it be, Mary?
I have a favorite genre, and it's like the detective shows where they
Yeah.
have something happens and you have to figure out what caused it,
Yes.
where it was. I think I really think that's kind of what
That,
blowing
yeah.
agent development is. You have a problem, in their instance, it's crime. So we have this issue,
Yeah.
and how do we get to solving it, identifying what the solution is or who done it? What's the who done it? But the who done it is, a new blowing agent or new
Yeah.
application. So it's, you work as a team on those shows, everybody brings their own skill sets to it. And so that's kind of what I would say it was.
Brilliant. Brilliant. That's a nice way to wrap it up. Thank you so much for
Thank you.
joining me today, Mary. It's been an absolute pleasure. You've been listening to Polycast by UT, helping your business expand in all the right places. Thanks for joining us. We'll see you again soon.